So now that we've seen all three of those trig functions, sine, cosine, and tangent, 8.5 we're going to look to expand on that by using the law of sines. So a law of sines can be used to find missing sides or angles in triangles that are not right triangles. Compare that with the triangles that we've solving before that have always had to be right triangles. We can find the length of all the measurements in a triangle if I know the measures of either two situations, two angles and the length of a side, so either angle, angle, side if it's not included, or angle, side, angle if that side is included. Or the other situation could be two side lengths that we know and the measure of a non-included angle. So that would be two sides, and then that non-included angle would be like side, side angle. So looking at that actual law of sines, for any triangle ABC, if we know the lengths of the opposite sides of angles A, B, and C are lowercase a, lowercase b, lowercase c, so that's how we're usually going to label our triangle. For example, angle A, across from that's going to be side A. Law of sines is going to relate the sine of each angle to the length of the opposite side. So that means that if I take the sine of angle A and divide that by the side A across from that, that should be the same ratio as the sine of angle B and the ratio of that side across from it, B. And that same thing will still apply to that third angle. So sine of angle C over C is going to be equal to those other two ratios. If we want to see why that works, we can still basically use that sine in terms of right triangles. If I can imagine taking that last example and dropping down in altitude, I can say that the sine of angle A would be this height over B. So again, that's opposite over hypotenuse. If I look at the sine of angle B, that's also h over A. So that height over the hypotenuse again. If I solve for h in both of those equations, I get b sine A and a sine B. Since I know h is equal to itself, I can substitute and use transitive a sine B is equal to b sine A. And if I divide, one last step, divide by b, divide by a, I'm left with my law of sines. So we don't have to derive that rule too much, but it's good to know where that comes from using our right triangle still. So let's put that rule into practice. If I have this non-right triangle and I'm given two angles and a side, again that would be angle, angle, side for a starting point, I want to use that to find the length of side BC to the nearest tenth. And side BC, remember we can call that side A because that's opposite from angle A. So if I'm using the law of sines, sine A over A, so sine of angle A is sine 48 degrees over the side across from it is equal to sine of 93 degrees over the side across from that angle. So again, sine of A over A equals sine of B over B. So if I'm solving for A, I can cross multiply as a first step. So 15 times sine 48 degrees equals A times sine 93 degrees. And then if I'm left with that equation, I can solve for A still by dividing out that sine expression. We got to remember that every time we divide, we can't just divide by the 93. Got to divide by that entire sine function. So divide both sides by the sine of 93, and we've got A isolated. So A would be 15 sine 48 all over sine 93. If we punch that into our calculator, we could find that to the nearest tenth. That would just be about 11.2. So trying the same thing, but this time trying to find the length of AB. So we call that side C. It's across from angle C. First thing we want to do is figure out what angle is missing there. If I know two angles in a triangle, I should always be able to find the third. So if I take 180 for the triangle and subtract the two that I'm given, I could find that that angle C would be 39 degrees. So now I can use my law of sines. Sine of angle C, which is 39 over C, should be equal to sine 93 over 15. We can use the same ratio from that first question, sine B over B. So same steps. First step, I'm going to cross multiply. So C times the sine of 93 degrees equals 15 times the sine of 39 degrees. I guess I just wrote it the other way around here. It doesn't really matter. But either way, if I'm solving for C, remember this is where we have to divide by that sine function. So if I want to isolate C, I'm going to divide both sides by this sine of 93 degrees. And that should leave me with 15 sine 39. So the left-hand side is going to be the numerator. And denominator is going to be that sine 93 that I divided by. So if I punch this all in, I should get about 9.5. That finds our answer to the nearest tenth. So we can also find angles. Last two problems were finding a missing side, but that same law of sines should allow us to find an angle that's missing. So in this triangle RST, if I want to find angle S, that would be the angle opposite of the 11 for a side length. So we're going to use that in our ratio. So again, law of sines, sine of S over the side across from it. So sine S over 11 equals the sine of 120 over the side across from that, which was 18. And here again, if I want to solve for S, I could start by multiplying both sides by 11. So I have multiplied on the right, also multiplied on the left, but I cut that off a bit. we know that sine s would then be 11 sine 120 all over 18. So again, I'm just multiplying that numerator. Denominator stays the same. And remember, just like when we were using our trig functions before, whenever I'm looking for an answer that's an angle, so whenever an angle is missing, I want to be thinking of that inverse trig function. So I can't just divide by sine. I have to take an inverse sine. So if I find this value on the right, 11 sine 120 over 18, if I take the inverse sine of that, so again, inverse sine of that entire expression, that should come out to about 32 degrees rounded to the nearest tenth. Same situation in part B, although they don't give you a diagram, my suggestion would be to draw one out first. If I have a triangle KLM, so I drew out KLM, we know that the length of LM is 9, so LM I've labeled as a length of 9. We also know a length of KM, which is 14. We know one angle, which is angle L, is 105 degrees. We want to use that to find angle K. And we can still use law of sines because I have an angle and two sides. So that's an angle that's not included and two sides next to it. So if I set up my law of sines, the sine of angle K over the side across from that, so sine of K over 9 equals a sine of 105 over 14. Set up my proportion. And then we're just looking to isolate for our variable. So again, multiply both sides by 9. That'll cancel out my division. Sine of K equals 9 sine 105 all over 14. And remember, whenever an angle is missing, got to be thinking inverse again. So if I want to get rid of this sine, I'm going to take an inverse sine, and that means an inverse sine of that entire expression. If I find that from the calculator, that should give me about 38.4 degrees. So again, just like in the last section, we're using our trig functions or right triangles. Still the same rules here. If I'm looking for an angle, I want to be thinking of using an inverse function. So an inverse will get me that angle. So one question on the back, which is a word problem. We have to figure out a ship's been sea longer than expected and it has only enough fuel to sail safely for another 42 miles. We're going to keep track of that because that'll be important. Port City Lighthouse and Covetown Lighthouse are located 40 miles apart along the coast, so that's drawn in the diagram here as that 40-mile distance. At sea, we can't determine distances by observation, but what we do know is that there's a 70-degree angle between the ship and Port City. Ship, Port City, and Covetown. And there's a 52-degree angle formed by those two distances and the ship. So using this drawing, we should be able to figure out which city, if either, I can sail to. And I just labeled that X and Y, although we could name those variables anything we want. And if I'm going to be able to use law of sines here, it looks like I have two angles and an included side. I'm going to be using that rule twice because I need to find it for X, I need to find it for Y. So a good starting place would be to find that third angle in the triangle. If I'm given two angles, remember I can start with 180 for the triangle and subtract the two that I already have. And that should come out to 58 degrees as the angle that's missing. So now if I want to use that law of sines, again, now I'm just looking for the sine of an angle and the side across from it. So sine of 58 degrees over 40 should be equal to the sine of 52 degrees over X. And same thing for Y. If I set up still using the sine of 58 over 40 for one ratio, I can then use the sine of 70 over Y to complete that proportion. So similar setup, we're using the same rule for the law of sines to find X and to find Y. We're also going to be taking the same steps, we'll just be getting two different values. So first step, again, if I want to cross multiply, that'll give me my X sine 58 equals 40 sine 52, or in this equation, same thing. Y sine 58 equals 40 sine 70, taking that cross multiplication step. And then similar step on both of these again. If I want to isolate for my variable, that means I have to divide by that sine expression. So divide both sides by sine 58 to isolate for X. Also same thing in our other equation. If I divide both sides by the sine of 58, I'll have Y isolated. So now that my variables are isolated, I should be able to find those values from the calculator. So if I evaluate those expressions, X should come out to about 37.2, and that would be miles, I guess. And Y would also be 44.3 in terms of miles. So now if we look back at our original question, remember that we only had enough fuel to safely sail for 42 miles. So if I think of X and Y in the diagram, if X was 37 miles, it looks like I have enough fuel to make it to Port City, but since Y was 44 miles and I only have fuel for 42, I can't make it to Covetown. So that's our conclusion. Ship has enough fuel to sail to Port City along the route that we used for X in terms of distance, but we don't have enough fuel for Covetown because we only have 42 miles of fuel and we would need 44.3. So make sure we have these questions solved, see if we have any questions to answer when we come back, and we'll work on some practice together.